Good evening. This is Brett Robley, your professor, ISDS 371, and this is the video lecture for Thursday night, February 16th. As we discussed, we decided we would not meet Thursday night because I'm going to be out of town, but we did not want to fall behind, and so students suggested I do a video lecture, and here we go. So I'm on the course website, and I updated to include string and reference in addition to input and output because we fell a little bit behind, and I want to touch on string and on references, which are used when calling functions and getting values updated. Yeah, we'll talk about that. Now, in the red letters, just to be clear, class does not meet tonight. Instead, you're going to review the recorded lecture that I'm creating now. So it's obviously not up there yet, but keep checking. I hope to have it posted by Sunday night, and that way you guys can get a head start. But if you don't, you're not behind because you can still view the lecture at 7 p.m. on Thursday, just as if I had shown up for class. All right. So let me go and let's get started. I'm going to go ahead and open my Notepad++, which is my program editor. And you Microsoft Visual Studio and Xcode people, go ahead and open yours. And let's start by including iostream, which we're used to seeing now. We use that for cout, for cin, which is short for console out or console in. Console out means we're displaying, console in means we're getting input, usually from the keyboard. There's also a console error and a console log. We haven't talked about those yet, but I'm going to go ahead and put it out there as a comment just so you guys start to wonder what that is. Don't waste your time looking it up. It's not worth your time. Now, we've talked about floats and we've talked about char. Or some people call it char. We've talked about ints. We've talked about doubles, bool, which is a boolean or a true false type of a intrinsic C++ data type. But strings we haven't really talked about. And strings are implemented in C++ through the standard library, which is why we have to call in the string routines using the brackets. But this will make it easy for us to get names, first name and last name and other types of strings rather than the single character input that we have been taking. So string is going to be helpful for us, and that's part of the C++ standard library. There's also C strings and maybe even some standard template library string, but that gets confusing. It's like, why so many strings? So let's just focus right now on the string that's provided by the standard library. Okay, and the reason we need to do this is because before we can do the file input and file output, we need to be able to use a string, and we need to be able to recognize and use what's called a reference, and we'll talk about why later. Okay, so in this program here, you've noticed I don't have any colorization, and that's because I haven't named my file yet. So I'm going to go ahead and name my file, and let me navigate to where I like to put my files for this class. Desktop and C++, and we're on February 16th, and I'm going to call this string.cpp. Yeah, I'm going to blow away one that's already there. That's okay. All right, so here we go. So follow along with me. Make sure that you're typing this code in. Make sure that you're able to compile this code and execute this code. Okay, so I'm going to use namespace standard, and again, you know why, but basically this tells the compiler to search the standard namespace, which is where all the standard library symbols live. We'll go ahead and start our main function here, int main, which says that we're returning an int. The parentheses are empty, which means we're not passing any parameters into main, although we're going to talk about that someday soon. All right, and let's say I want to write a program where I ask the user to type a first name and a last name in at the console, and then I'm going to show you how to do that via functions, and I'm going to show you what the effect is when you take this input at the console and try and fill in the variables. One way it's going to fail, and one way it's going to work. So let's get to it. So first of all, I want to say string, which I can do now because I have included the string up there. So I'm going to say fname, and that's going to stand for first name. And now I want to initialize it to a word called empty. The double quotes means that it's a string. And you may not have seen this before, the curly braces instead of an equal sign. And I'm just showing you, incrementally different language features as we go, because I don't want to overwhelm you by showing you too much at once. So this actually is the preferred initialization syntax these days. But in order for this to work, you need to compile this with C++, I want to say 14. It might be 11. I'll have to go check that. No, you can do it in 11. So C++ 11 or higher. Okay? Now, string lname, that'll be for last name. That'll be our string variable for last name, and I'm going to initialize it using empty, the double quotes. And why didn't I use the curly braces? Well, not everybody has C++ 11, let's say. So if you have a compiler that's older than C++ 11, then you can use this method for initializing your string. Okay. All right, so that allows us to set up our two variables that are both strings, and a string is really defined as 0 or more characters. Now, you might ask, well, is this going to work? Yeah, I'm going to compile, when I compile this, I'm going to compile it with C++ 11 or higher, and so it's going to recognize line 8, and it's going to initialize fname to the string called empty, and it's also going to recognize line 9, even though it's an older way of doing it, and I forgot my equal sign, so we'll fix that now. There we go. And it will recognize both of those. Okay. All right, so now I'm going to print a message to the screen, and I'm basically going to instruct the user, hey, let's go ahead and let's do a pass by value first. We'll say pass by value. And that means that when we make a function call, we're going to copy any parameter data that we pass to the function, and we're going to operate on a copy rather than operating on the original. And that means we're not going to use an ampersand. And you might go, well, what's the ampersand? Well, that's the reference, okay? That's what's known as a reference, and we'll get into it. Okay. So then, I believe I will go ahead and call, I think I'll say get name. I'll say get name by value. And normally you wouldn't say by value, but I'm trying to illustrate what I'm doing here. And let's see, I'm going to want to print a label. So I'll say like first name, and then a comma, and then I'm going to pass in fname. And the idea is that when we make our function call, we'll print this first name to the screen so the user knows what they're typing, and then they'll type in their first name. And the idea is that calling this function and passing it two parameters, a string literal and a variable, that in the function will be grabbing the keyboard input and hopefully storing it in this variable here, which lives up in main. Okay? And let's see, we're going to also get the last name. So I'll say get name pass by value, and I think I want to say pass by value there too. Okay, and I'm going to say, all right, let's get the last name and L name. We'll pass that variable. So we're passing two variables in. Anybody who is experienced with C++ might be wondering why I didn't do something else with these string literals, but I'll come back to that. Okay, and then let's print some more stuff. So assuming that we've made these two calls and we got the first name and last name from the user, then I'll say hi space, and then I'll say f name for the first name, and I'll use a plus sign and a double quote space double quote and a plus sign and L name. Okay, and I'll walk you through that. And then let me do double quote space, no space, exclamation point, and we'll put a new line in. Okay, so what's going on here? So I'm basically outputting to the screen hi space and then the value that's in f name, and then the plus sign. When you're dealing with numbers, that means add two numbers together. But when you're dealing with strings, it means concatenate or glue these strings together. So I'm gluing together out of three strings, f name, a literal string, which is a space, and L name, I'm gluing those three strings together for the purposes, or for the purpose of outputting Brett space Robley, or Gary space Smith, or Mary space McDonald, right? So the plus sign says glue these strings together. That's what that's about. Okay. All right, let's move on. So now I want to show you, oh, I have an error. I see it right now. Go ahead and I'll put my double quote in there. All right, now I'm going to say \n, so I'll issue two line feeds or two new lines, and I'll say pass by reference. And I think I will say that's with the ampersand. And let's put a new line in there. Okay, now I'm going to say get name pass by reference. And I'm going to do the same thing. First name, f name. And I'm going to say get name pass by reference. And I'm going to say last name and L name. And then C out. Hi f name concatenate with the space, string literal, concatenate with L name, so glue those three together. And then let's get my exclamation point out there, \n for the new line, boom. All right, so that's our main body. Now, I need to go implement these functions, get name pass by value and get name pass by reference. So I go down here and we're not returning a value, so we use void, and I say get name pass by value, and I'm going to be passing in basically a string as the type, and I'll call this a field label, because really I'm using this, intending this to be used as a display on the screen, kind of like when a person's filling out a form. And then I'm going to say string, and I'm going to say name. Now, why didn't I say f name? Well, I'm going to call it twice, right? I'm going to call it first to get the first name and second time to get the last name. So when I'm calling it, I pass it the first name and last name variables, but the function just cares that it's a name, and you'll see kind of how that works. All right, so let's see, how am I going to implement this? Well, So I'll go ahead and I'll output to the screen. I'm going to output the field label. Okay, field label. Now, what is the field label? Well, this literal string, first name colon space, is passed to this function. Now when control jumps down here, it says, hey, I've got a string and it's called field label. So when I say cout field label, it's actually going to display first space name colon space on the screen, and that's how I kind of get my little form going. And then I'm going to say name. Oh, I'm going to say cin. I'm going to wait for the user to type in their first name. I'm going to store it in name because that's how the function knows, right, what this is. Okay, and then when the function falls through the bottom, I'm not returning a value, but hopefully it's updated fname, because when we took the keyboard input to name, that maps to fname here when we made the call. Okay, so locally or internally to the function, this second parameter is known as name, but up here in main we actually passed it the variable called fname, and we're hoping to fill this in with the user's first name so that it doesn't say empty anymore, it says Brett or Gary or Mary, etc. Okay, now that'll get called twice. The second time it gets called, the field label will display last name, and we'll wait for keyboard input. That'll get put into the local variable called name, and we're hoping that will fill in lname so that by the time we get back to the main program and we output to the screen, we should say, hi, Mary Smith. Okay, and then we're going to do the same thing a second time, only we're going to call pass by reference, which is a function we now have to go implement. So void get name pass by reference, and same thing, I'm going to say string field label, comma, string, only here's where I'm going to do something different. I'm going to put an ampersand after the string, and the way you read this is you say, okay, I'm expecting a variable when somebody calls me, when somebody calls get name pass by reference, I'm expecting them to send me a string, which is called field label, and I'm expecting them to send me the reference to a string, and I'm calling it name. So what's this idea of a reference? Well, remember, variables go into memory. When we create a variable, when we declare a variable and we define it, we initialize it, the compiler actually puts statements into machine code that say, hey, I need some space in memory, and I'm going to give it a name, and memory has addresses. Memory is accessed based on its address. Just like you go to your friend's house, 123 Main Street, that's the address. That's how you get to their house. So when you pass a reference to a variable, instead of passing the value or the contents of that variable, you're passing an address to where that variable is stored in memory. And the hope then is that when we make a change here in the function, it's not going to make it on a copy of the variable that was called up here. It's actually going to fill it in. Okay, so I'll say cout field label, and then I'll say cin name, and the only difference between this function where we pass by value and this function where we pass by reference is right here, where we expect a reference to a variable, and here we get a copy of the value of the variable. Okay? All right, one more thing. We're very defensive when we program. We want to be very defensive when we program. And so therefore, a string literal should not be updated by your program, right? It's just there as a label. And so we need to be careful that we call it a constant string. We're passing a parameter and we're telling the compiler, don't let me write to the field label. If I do, that's an error. Why would I change the field name? I wouldn't. So I need to make that a constant. Okay? All right, now remember, we talked about this in class. I won't be able to compile this because the compiler doesn't know about this variable name on line 12 and 13. I'm sorry, this function name on 12 and 13, or this function name on 17 and 18, because it's never been declared anywhere. It's down here. This is the first time the compiler is going to see it on line 12, and it's going to say, I don't know what that is. I'll go ahead and compile it without the function prototype, just to show, or the forward reference, just to show you the error again. Okay, so here we go. Let me save this off, and who knows, I might have some other errors. They're easy to make, but so I'll go to my command window. I'm going to go ahead to my desktop and to C++ and to Feb 16. Okay, so here I am, and I have string.cpp. You can see it here, 11:48 p.m. Saturday night here. 844 characters. All right, let me try and compile this. So I'm going to say C++. I'm going to compile it using the switch that tells it it's conformant to C++ 11. And then I'm going to say string.cpp, and let's see what happens. Okay, so right here it says, hey, on line 12, get name passed by value was not declared in this scope. It doesn't know what it is. And it says the same thing about get name passed by reference. Okay, so the fix for that is to come down here. I'll go ahead and copy that line, which gives the return type of the function called get name passed by value, as well as the variable types that need to be passed to the function. I'll put them in here. I'll end it with a semicolon, and that really becomes my function prototype. Excuse me. I'll go ahead and grab the pass by reference, which is this one. Control C, copy it. Control V, paste it in. End it with a semicolon. Control S to save it. Alt tab to get back to my box, up arrow, and now boom, that's great. It compiled. Let me run it. Let's see what happens. Okay, in my world, when I compile something without telling it a name, it comes out as a.exe. The Visual Studio people, I'm not sure what the default comes out to. I think it takes pains to give you a nice name. So I'll come back here and I'll recompile this, and I'll say -o string, and that should compile it and give me a string.exe, and sure enough, there's my string.exe. So I'll do CLS to clear the screen. I'll type string, enter, and it's like, okay, pass by value. This is going to send a copy into my function. We're not using the ampersand, which is a reference. I'm going to say my first name is Brett. My last name is Robley. I'm going to hit enter, and it says, hi, empty, empty. And so what happened there is when I initialized the strings fname and lname to empty, I then called by value, and it made copies of fname and lname and passed it to my function, so that when my function operated on it, it all worked. But when the function ended and it came back to main, we hadn't touched either fname or lname. It didn't update those because we operated on copies of the values of these two variables. Well, now I'm in the pass by reference, and this is where I do use the ampersand, where I say, hey, I'm going to tell you, function, the address to fname and lname in my main program. And now I'm going to get my keyboard input. I'm going to say my name is Brett Robley, hit enter, and notice now when we're down here, it says, hi, Brett Robley. So instead of hi empty empty, it actually, in the function body called getNamePassByReference, it actually got the address to fname and the address to lname. So when I got my keyboard input, I actually updated the values in these two variables. And that's the difference of pass by value and pass by reference. Okay, I'm going to pause the video and regroup to make sure it's recording.